So ladies and gentlemen, let's go ahead and look at the lab reflection for Unit 3. And the question is the molecular geometric shape for pH 3 tetrahedral according to the VSEPR theory? So before you can figure out the geometric shape, you need to draw the Lewis molecular structure. So first thing you want to do is draw the structures for the individual atoms. So given I have pH 3, and we know that H's are always on the outside. And the reason they're always on the outside is because they can only hold 2 valence electrons. And they can only form one single bond. So looking at our structure here for phosphorus, we know phosphorus is in group 5. Okay, or group 15, so that means it's going to have 5 valence electrons. So when I draw my 5 valence electrons, I can see phosphorus can make 3 single bonds, 1 double bond, or 1 triple bond. When I draw my Lewis structure for hydrogen, I only have 1 valence electron. So we can see that the hydrogen can fit nicely right there, and because we have 3 of them, we're just going to place these hydrogens right there on the outside of our phosphorus. So when I build my molecule, I am making 3 single bonds with hydrogen, and then I need to put that remaining lone pair on my phosphorus. Every element wants to have 8. That is why they bond. So in a covalent bond, we are sharing those electrons, and we need to make sure that we're not forgetting the leftover 2 electrons that are on phosphorus, because if you forgot to put those there, we then would have a completely different molecular shape. And you also would not be satisfying the octet rule. Okay, so now we're ready to answer our question. So looking at our structure, we can see we have 4 domains. So a lone pair counts as a domain. So you're counting your domains based on your central atom. If I have 4 domains and 1 lone pair, I can look at my shape sheet. I'm going to find 4 domains, and I have 1 lone pair, so that tells me my shape is going to be trigonal pyramidal. Now the question was, is it tetrahedral? So when you're answering your claim, don't tell me that it is trigonal pyramidal, because that's not the question. The question was, is it tetrahedral? So my claim is going to be, according to the VSEPR theory, the molecular shape is not tetrahedral. Okay, 1 sentence for your claim. Now for our evidence, the only evidence we have is the shape that we drew. So what you should be including in your evidence is what you see. So the molecule pH 3, it has 4 electron domains around the central atom P. It also has 1 lone pair on the central atom P. Okay, that's my evidence. You don't have to tell me in your evidence section that it's trigonal pyramidal, because we need to look that up on our shape sheet. So all you need to tell me is what you know from your drawing. Now when we go into the reasoning section, this is where you're going to be very thorough and explain why your claim states that it's not tetrahedral. So a molecule that has 4 electron domains with 1 lone pair is trigonal pyramidal. If the molecule had 4 electron domains and 0 lone pairs, it would have been tetrahedral. Okay, so right there, if you gave me those 2 things, that's very strong. That's a great reasoning section. However, if you look at the prompt on your lab, it also wanted you to talk about how electrons repel each other and also the VSEPR theory. So that's where I'm going to add 1 more sentence. I'm going to say that atoms in a molecule are spaced as far apart as they can because electrons repel each other according to the VSEPR theory. All right, so that reasoning section was, we have 1 sentence, 2 sentences, that's 3 sentences. So when we're doing our CERs, I typically tell you the claim is always 1 sentence. So don't give me more than 1 sentence. Evidence, usually between 2 and 3 sentences. And then your reasoning, maybe 2, but usually 3. Okay, so this here would be a perfect CER, and that would get you a 100%.